In the summer of 1997, acoustic researchers captured an anomaly in the Pacific Ocean. The signal was immensely loud, registering on sensors thousands of miles apart. If an animal made this noise, it would have to dwarf any organism currently known to science. The hardware that caught this recording was never meant for marine biology. It was SOSS, a global web of underwater microphones originally built during the Cold War to track the movements of Soviet submarines. Analysts spent decades staring at readouts from this network, trained to isolate the faint mechanical heartbeat of an enemy propeller creeping through the deep water. On August 19, 1997, a civilian lab reviewing declassified SOSS data noticed a band of color that deviated from the standard library of submarine or tectonic signatures. The signal was a massive, low-frequency rumble. It swept upward in pitch along a smooth, deliberate curve, sustaining that energy for 7 straight minutes. For a sound to travel 3,000 miles through the crushing pressure of the deep sea and still arrive sharp enough to be clearly identified, the source required immense raw power. Humanity had wired the entire ocean to listen for the engines of war, only to accidentally eavesdrop on a different class of anomaly altogether. The lead of NOAA's acoustics program noted that the signal had the rising frequency curve and rapid amplitude variation typically found in the acoustic profile of a living marine creature. This chart shows the scale mismatch at the center of that theory. To generate an acoustic footprint of this magnitude, an animal would have to be substantially larger than a blue whale. No animal of that size exists in the fossil record, modern biology, or the documented ecosystems of the open Pacific. This discrepancy allowed the bloop to leak into pop culture, fueling theories of ancient sea monsters and deep-water artifacts. With the scientific method unable to find a biological match, the public was left with a persistent mystery that highlighted how little of the deep ocean we had actually mapped. Following 15 years of speculation, NOAA updated their official stance in 2012, treating the case as effectively closed. The new official explanation was a cryosysm, an icequake. A city-sized slab of ice had likely snapped off the coast of Antarctica and ground itself against the seafloor. As researchers compiled a library of these glacial fractures, the 1997 recording was found to broadly align with the frequency sweep and duration of other known cryogenic sounds. For most, the mystery was resolved by mundane geology. The roar was the sound of falling ice, and the file was moved to the archives. In 2024, an independent group of acoustic researchers revisited the 1997 file, applying modern diagnostic tools to the original raw recording. This chart layers the 1997 bloop directly over a confirmed icequake. You can see where the data fails to align. The bloop's peak energy is narrower, and its rise time is slower. Geographically, it crossed thousands of miles while retaining a sharp peak models cannot perfectly replicate. While an iceberg remains the best working theory, a specific fraction of the original signal resists the model, leaving the case in the narrow zone between solved and unsolved. Since 1997, global hydrophone networks have expanded. We have more sensors and higher recording fidelity than ever before. This creates a statistical outlier. If the bloop was a routine class of glacial event, the sheer volume of our modern data suggests we should have recorded its twin by now. In nearly 30 years of relentless listening, the ocean has never produced that exact sound again. This leaves the final conclusion to the data. Do you accept the imperfect icequake model, or is there a variable in the deep ocean we haven't accounted for? Share your reading of the signal in the comments. The loudest unidentified sound ever logged by NOAA remains a singular event in the archives. This nearly 30-year silence suggests the 1997 signal was less a routine occurrence and more a reminder of the mysteries still held within the deep.